Hello, my name is Mike Rockwood. I am the Technical Director of Research and Development for Savvy Corporation in Santa Ana, California. What we are here to do today is to install a dyno cap on a 2011 Kia Sorento. The reason we're installing the dyno cap is because the PCV valve basically is inaccessible on this vehicle. And for us to pull vapors efficiently out of the crankcase, we will do that through the oil cap. So we have a dyno cap which has an adapter built into it for the actual dyno valve to pull the foot right into the valve and to the cap, and it works very well. So therefore we can run the dyno valve and have it in addition to the stock PCV system. Basically it is independent from any vehicle onboard diagnostics computers. The electronics are very separate from the whole system. So basically we're going to pull vapors and keep the oil cleaner longer and make the engine run better, leaner, less emissions out the tailpipe, longer engine life, longer engine oil life. Step one in the process will be basically finding the trigger, which is the RPM reading for the microprocessor of the dyno valve, which is a very simple deduction of figuring out from the injector which wire is the pulse wire. And it can be done very easily with a diode test light. Basically we need to gain access to the injectors, and we've installed our trigger wire to the negative pulse of the injector. One is positive, one is negative. That gives us our trigger for the microprocessor. Step two is to find the power source, ignition switched on, which can be done from the power distribution center or from the fuse box, which is usually underneath the dash on most vehicles. With a test light, locate a fuse that is usually very low amperage, that is energized with the key on. Basically on this vehicle we used a 10 amp and we piggyback the fuse. Basically it's a 10 amp that continues through here and keeps the circuit alive that was originally plugged into there. This here circuit goes through this wire, which is your dyno valve, which you've noticed it's like a 2 amp fuse, so it's very low amperage. Now this circuit is protected originally through here, and the circuit is protected by the dyno valve through here. So it's totally independent. It's like two circuits into one. There's hardly no amperage draw, so it's not going to affect anything on that circuit. And of course your ground wire, which we have hooked up. I ran it back through here and hooked it up to a ground basically down there. If you can see that, the red connector right down in there. So it's a good solid ground. That's where the factory actually has their grounds hooked up. Basically, step three would be to find a solid vacuum source in the intake manifold. And on this engine, it's right up top. It's very easy to get to. Just disconnect, and then we put in a T. So we're just going to T into the original vacuum system. Like that, and like that. Very simple. And of course you must install the clamps back on there to make sure everything's secure, which I will do in a moment. Then we have the dyno cap. Pull off the original. And the dyno cap. Put the dyno valve on. And the vacuum line. Very simple. This is black harness, black connector, self-explanatory, very simple to hook up. Hook them together, slide this lock, so they are now locked firmly in place. power wire, which is right here, which is the same procedure. Locked into place. This one is for the controller, which is right here, the blue. It's got arrows that help you identify which way to plug it in. Lock it into place. You want to support it someplace where it doesn't really receive a lot of heat. Up here was a good place, and that's where I decided to put it on this vehicle. It's plain and simple, and it's very visible to see the flashing light when you start it. Okay, step 4 would be to, after everything is installed, making sure that all the wires are secured and insulated, that you start the engine and observe the controller. Basically, the controller has an LED light that when you first start the vehicle, it will flash red for approximately 4 minutes. After that time, when the engine is warmed up, you will give the engine RPMs, and over 1250 RPMs, the light will turn blue. And when that light is blue, the DynoValve is actually opened up inside and pulls vapors from the crankcase back into the intake, allowing those hydrocarbons to now be evacuated from the crankcase and through the intake provide another source of fuel for the engine and actually provide a leaner condition for the emissions. The very last step in the process is to hold the valve to make sure that it opens. It open, comes to an idle, it closes. So you can feel it pulse in here when it opens and when it closes. It should always be closed at idle. In every package there's an identifying sticker, basically that identifies our product. Basically this tells people that it's an Air Resources Board Executive Order number that has to be posted on the vehicle anytime you install any aftermarket item on a vehicle. It should be ARB approved. So this product is. Properly identified. Basically with a dyno cap, it is independent. It's like having 2 PCV valves on your engine. So you've got the stock one that works adequately to relieve the pressure, and you have the DynoValve to remove the vapors. When you have the oil changed, it's a very simple matter of lifting the DynoValve off of the cap, setting it aside so you can efficiently change the oil and put new oil in. It's very simple.